increases by $3,000 per year. So that's question 16 there. So is that linear, exponential, or neither? Well, let's make it up. What's his salary? Just make it up. Doesn't matter.
$3,000.
His salary is 3,000?
Sure.
Well, the increase is 3. Well, I'm just going to give
the increase
50.
is 3,000. Okay.
I'm
There we
going to
go.
give him
50
50.
grand.
Right? So the next year it'll be what?
100,000.
It'll be 53,000. So the next year it'd be
56,000.
okay. There we go. And then 59,000.
59.
Right? Okay. So each year it's increasing by
$3,000.
okay. All right. So because the increase as the x's, the inputs go up by the same amount and the y's go up by the exact same amount, this is linear. Okay.
Right.
Okay. So that means linear. And if you graphed it, straight line. See that?
Gotcha. Yep.
Makes sense because look, it's each year it goes up by 3,000, so you got a nice straight line graph, right?
Perfect.
All righty, so and you can see this, okay, right? So Mary's salary, going to start her out at 60,000.
Okay.
And it says that Mary's salary grows by 3% each year. So what would she have after the first year?
Let's see. Hold on.
Right. So basically, if you take 3% is 0.03, right?
Right.
So if I go, what's this straight? 1.03. If I multiply the 60,000 times 1, I get back 60,000. If I multiply by 0.03, I get the 3%. So if I just do that times the 60,000, and I'm just going to click on, I mean, I can type in 60,000 if I want to and press enter, or I can actually, in Excel, by the way, I can just, watch this, just click on that and it'll take that cell B8 and multiply it. And now I've got 61,800. Okay.
Yep.
So what was the increase amount? It's this minus this, right?
Right. So 1,800.
Went up by 1,800. What would Mary's salary be the second year though? Because it increases by 3% each year, which means 3% of the previous year added on again, right?
So it's 63,654.
Right. So I can go 1.03 and times that by the previous year.
Yes.
And I get 63654. And then to get the increase, I go equals this minus this.
Right.
Enter.
Yes.
And is that the same increase as the first year? And why? And
no.
if it's not, and why is it more?
It's $54 more.
Right.
Because of the 1.03 increase per year.
Right. Like the first year we got 3% of 60,000
right.
and added it on. Now we're getting 3% of 61,800 and adding that on. So it's a bigger increase. And the third year, just for fun, 1.03 times that. For anyone confused, I made these numbers up. I didn't make up the 3%. That's the only number we were given in the problem. But the point is, the next year it increases by even more, 1909.
1909.
So this is increasing by a percentage of the previous year, and that means that we have an exponential function here, right? And just for fun, watch what happens when I graph this. Yeah, nothing. It looks straight, doesn't it?
It does look absolutely straight.
Looks absolutely straight. So it looks like a linear. Huh. Well, it almost is. It's very close to linear. And with the numbers I gave it there, we're not doing it justice. But I'm doing a little Excel trick. Going to extend this whole situation for many years. This is going to work for, oops. Okay, if I do an Excel trick here and I extend this pattern on and on and on for a bunch of years, let's have Mary work for 30 years and see what happens to the salary. Now, let's see, let's get, yeah, 30 years. All right. Okay, so have her work for 30 years and then see if we can see an exponential graph. We should see a curve. There we go.
There we
See that
go.
curve?
Yep.
Right. Okay. Now it's only 3%. If it was more than that, it would be a steeper curve, right?
Right.
But it's not a straight line. So your exponential, it gets, and see how her salary here, the increase is getting more and more because it's 3% of the previous year, right?
Exactly.
Okay. Cool.
I love it.
Okay, so the next one says that water is pumped into a tank at a rate of 10 gallons per minute. So we're just given one number, 10 gallons per minute.
Right.
Okay, I'm going to say initially that's minute 0, then there's 1 minute later, 2 minutes later, 3, 4, 5. How much water is in the tank initially? How many gallons? Make something up. It doesn't matter. We'll just make it up.
20 gallons.
Okay, so we start with 20 gallons in the tank. All right, and so if it's increasing at 10 gallons per minute, after the first minute, there'd be 30 gallons in there, right?
Correct.
After the second minute, 40. After the third minute,
50.
all right. After the fourth minute, okay.
70.
Making sense? So that every minute the tank is filling up with more gallons of water. And so the increase after the first minute is 10 gallons. After the second minute is 10 gallons and so on. Does that make sense?
Yes.
Okay, so that's what's happening there. And if we were to graph this, then it would be straight line.
Right.
A straight line graph implies we have a
Linear.
linear function. And the fact that the increase is exactly the same amount implies this is a linear function. Awesome.
Got it.
So we have an ant population that is increasing at 2% each month. So we're just giving one number in that whole problem, 2%.
Right.
I'm going to make up another number just for fun.
Okay.
Because I like to make table, I like to make graphs, so I can explain it to myself and maybe you guys as well. But there's a bunch of months happening, month 1, 2, 3, 4, 5, okay? Yep. And there's ants, right? And what's their initial population? Should we just say like 1,000 ants with that?
Sure, that works.
You can imagine ants at 1,000. So after 1 month, there's an increase of 2%, okay? And again, like 2%, what's 2% of 1,000?
20.
Right, that's 20. So it's increasing by 20. So there should be, 1,020 after the first month. Are we all clear on that?
Yes.
Now, the cool way to do that is to go equals 1.02 if you times 1,000. You see, if you multiply a number by 1.02, you're going to take that number back, the 1,000, and you're going to get the 2% as well, which is awesome. So we can go 1.02 times 1,000 and get our 1,020, right? Even cooler actually is to, in Excel, which we'll do later. And you guys don't have to use Excel. I'm just doing it to make the point, make these clear. But 1.02 times this, which is the cell B2. See that star B2? Enter, that'll give us 1,020, right?
Gotcha. Yep.
And then to get 20% for the next month, this is the trick. So we've had an increase of 20 ants, basically, right? You're okay with that?
Yep.
So for the next month, how do we get the next population of the next month?
You're going to add another 20%.
Right. So we're basically getting 2%, 0.02 times our 1,020, right?
Yes.
Which is 20.4 ants actually.
That's
and we're
correct.
going to add the 1,020 as well.
Yep.
So to get that, right?
Wow.
Which is a little bit, it's 0.4 more of an ant, which doesn't make any sense in real life. That's a dead ant. But in any case, It's 1.02 times, oops, sorry, times the previous amount. That's the cool way to do it. 1.02 times the previous amount gives us the same amount back and 2% more. And so this time our increase is in fact 20.4.
0.4%.
Because it's 20.4 more than the last time, right?
Right.
And then for the next month, it just goes on. So equals 1.02, times the previous amount. And we get this. Now the increase is this minus the previous amount, which is actually 20.8. So what's happening to the increases?
We're going up.
They're going up. Each month we're getting more ants, an increase of more ants than the previous month.
Yes.
Does that imply a linear or exponential function?
That's going to be a linear function.
So this is exponential because the increases are changing. They're getting more
they
and
are.
more.
You're right. Absolutely right.
Right. The previous ones were linear. If that was just this, if it was just 20 more ants every month exactly, that would be linear.
Linear. Yep. But we're not.
Right. But because the increases are what you call it, more and more.
Yes.
Each time, that means it's exponential.
Exponential.
Now, I'm going to do a cool, I'm going to do my cool Excel trick. I'm going to highlight these rows, grab this little thing in the bottom right here and just kind of increase and see what happens. All right, so I've just formatted the cells to make the numbers nicer. But if I do my cool Excel trick, highlight the rows, grab the little black plus and just drag your mouse down. And after 165 months, many months, let's go to like, what do we go to? We'll go to 240 because that's like 20 years.
20 years. Okay.
Isn't 240 months, 20 years, something like that?
There we go.
Because I just want to see if we can show you an actual curve. There we go. Okay. Yeah, I just want to see if we can show an actual curve on this for the exponential function rather than a straight line. Okay, quick analysis, charts. Yay, there we go.
Hey, we got it. Look at that.
All right, so that is our exponential. That is not a straight line. That is more, the more ants there are, the more ants to make more ants. Make sense?
Absolutely.
Keep shooting up until we get an anteater in this forest. These ants are just going to keep going, or maybe they'll run out of food, right, or something. But these ants are just going to, because it's 2% of the previous month's amount. So the more ants you have, the more ants you're going to get. And that's why by the end of the 20 years, they're up in the like 2,000 extra ants every month. See that?
Yes.
So that's what's going on with the ants. So that's an exponential function.
Got it.